Levers are simple machines that allow us to change the direction of a force or even increase the force through mechanical advantage. In this lab, we're going to build three classes of levers. Class 1, the seesaw, like this one built right here. Class 2, the wheelbarrow, where we'll have the fulcrum on the table and lift the weight up, the wheelbarrow. And then Class 3, where we have the effort force midway down, we can throw the resistance like a broom or even casting a fishing line. Here's what you need. For this lab, you're going to need a meter stick, carefully marked with all the readings on there. These numbers will help us to determine the placement of our effort and our resistance forces. You're also going to need a little clip here that keeps your fulcrum moving around at different measurements. And a little stand to hold the fulcrums. Set of weights. Namely, you're going to need the 1,000 gram weight and the 200 gram weight. And you're going to need a pair of spring scales. We have a 500 and a 2,000. Here's how you do it. The setup's pretty simple. All you need to do is take the meter stick, make sure the clip is attached right to the 50 centimeter mark, right dead center. You can see the 0 there for the 50. There's 40 and there's the 60 over here. Okay. Paper clips. Have them hang down. So when you put them on, you slide them on there, they hang down on both ends. One end will be the effort, one can be the resistance. Okay. Put it on the stand as such. For class 1, you're going to need the 1,000 gram, 1 kilogram weight and the 2,000 gram spring scale. All right, the first part it says to go to 40 centimeters each. The distances that I give you on the tables is from the fulcrum. So the very first one on class 1 lever says 40 centimeters. So if our fulcrum's at 50, we have to go out 10, 20, 30, 40. That's 40 away from the fulcrum, okay? And that can be my resistance, that's the weight. On the other end, it says 40 also. So there's a 50, a 60, 70, 80, 90. So I slide that out there. That's now 40 and 40 from both ends. Put it on the stand. I put my weight on the resistance end because it's 40 away. Now you gotta hold on because it's pretty heavy sitting out there. Now, key to help you is to take the meter and put this over at the sink so you have some room to go down and hold the meter. If you try to do it on the table, the meter will crash into the table. So I'll try to slide this over to help you show how this works. Take the meter. And now, from 40 and 40, and working alone is not always good. I can pull down and I can get, all I want to do is hold it steady. I can look at the readings on the meter, enter that in the table. Next, go to the table, it tells you to move this into 20 centimeters. So slide this down 20 centimeters away from the fulcrum. Then I think it has to go down to 10. Last one for stage 1 is you put the effort, the scale, down to 20 away from the fulcrum, and you move the mass back out to 40. Enter all those into the table, and we'll show you how to calculate AMA and IMA later. Class 2. Class 2 is a wheelbarrow situation. First thing you'll do is you'll slide the clip for the fulcrum down to the 10 centimeter mark. It's 10 centimeters from the end, right? And this is at 10 exactly. Put that on a stand. You're going to want to have both paper clips on the same side, on this side of the ruler. Now, it's a wheelbarrow, so the load, which would be the weight, is going to be down here. So you're going to hang that paper clip on the bottom yet. But the one you move from that side over to this side for class 2, have it sticking up because you're going to be actually lifting on this side for the effort. So there's your wheelbarrow. With the wheelbarrow, your hands are here, your load of bricks are here, and the wheel's down there. And you just want to steady out to get a nice balance here. Now the distances again are from the fulcrum. So if it's 20, it's 10, 20. If it's 40, it's 10, 20, 30, 40. But check your table to make sure that the effort and the resistance are the proper distance from the fulcrum. class 3, we got to remove the stand, and we're going to set the end of our lever on the tabletop. Now you're going to need a second person to hold that steady. Then you're going to take a 200-gram weight. It's much smaller than the 1,000-gram. In fact, from the box, it's still in the end. See where it comes from? The very end. Here's the big one, the 500, and then the 200 is down at the very end. Okay. That's going to go out here on the very end. That's your resistance, the 200-gram weight. The spring scale, now you're going to use the 500 scale, put it here. Now again, you've got to have somebody holding that end, because watch what happens. If nobody holds it, it lifts up in the air. Someone's going to hold it down. And then you're going to, your distances are always going to be from the fulcrum down here to the effort, and then also distance to your resistance force, again, by centimeters. Do different distances, enter the data in the table. Now go to the calculations. Calculating AMA and IMA is the same as we did with the inclined plane. For AMA, you're going to take the effort force, that's the amount you pulled on your meter, and you're going to divide the weight that you use, 1,000 grams for class 1 and class 2, divided by the effort force that you had put in, that's column 4. IMA, you're going to take the distances from the fulcrum. So you'll take column 3 divided by column 2, and the numbers are right here for all different classes. So the IMA is pretty easy, the numbers are right here. The AMA are going to be the actual forces divided by the weight. Don't forget, for class 1 and class 2, it was 1,000 grams. Make sure you use the number that you calculated or weighed. And for class 3, you use a 200-gram weight. Do the questions, you're all set. To calculate efficiency, we're going to take your IMAs and just divide it by the AMAs from your data table. Now we're only going to do this for the second class levers only. So there's 3 positions, A, B, C. Just take your values of IMA, divide by the AMA that you've already calculated, and put your efficiencies here. And we're all done. They should be, less than 100%, but should be pretty high. I'm thinking they're probably better than 80%.